welcome to another Mr. Paul video. Today we'll be discussing what does it mean to be identifying and representing functions. Okay, so let's first get a few things out of the way. For the last few days, we've been talking a lot about y equals mx plus b. And we've been talking a lot about what the b means, and we know this to be the y-intercept. And we also talk about what does m mean, and that's known as the slope. But oftentimes, we overlook two other letters. That is namely the x and the y. These also have special names. We know these as x being an input, and y is called an output. X is called an input, and y is called an output. So when we were younger, well, at least when I was younger, we used to play this little game, and that had to do with a machine. And this very special machine would do stuff to numbers. Okay? So numbers that would go in would be called inputs. These are numbers that I put into my machine. And then what my machine would do is it would do some magic, and then out would pop another number. We called those outputs. So for example, what I would do is I would throw in a 1, my machine would do its magic, and out would come a 3. If I put in a 2, my machine would do its magic, and then out would come a 4. I put in a 3, my machine would do its magic, and out would come a 5. I put in a 10, my machine would do its magic, and out would come a 12. And then I would pose the question, what does my machine do? What does my machine do? And then you can pause the video and say, okay, my machine does this. Well, this is how we represented the idea of functions. This was later known as a function machine. As we would decide what would happen if I threw in an x. What if I threw in an x as an input? What would this machine do to my x? As you've probably already figured out, it would add 2 to the x. My machine takes my x and then adds 2. And then what would come out would be equal in value to my output, which was y. So x would go in, and then what would come out would be y. So we would write x, add 2, and that's what would come out, which would be y. So I want to take a moment to build on this idea, but we're not going to have to build machines anymore. We're going to be learning through what's called a Venn diagram. A Venn diagram. This is a Venn diagram. And once again, this is another tool to describe what happens between inputs and outputs. So, to first understand what inputs and output happens, let's just first make 2 large circles. This circle will represent the inputs, where all of the numbers that I'm going to list in here would be numbers that I would put into my machine. And then this bubble right here would represent the outputs. And all the numbers in here would be the numbers that I replaced, or all of the numbers that would come out of my machine. So for example, when I put in a 1, out came a 3. So what I would show in this Venn diagram is when I put in 1, I would show with an arrow, and it would point to the 3. And this would indicate that when I put in a 1, out came a 3. When I put in a 2, out came a 4. So I would indicate that with an arrow. When I put in a 3, out came a 5. So I'd also indicate that with an arrow. When I put in a 10, out came a 12. And then when I put in an x, what came out was y. And then the question is what does this machine do? And we would say that the function machine added 2, x plus 2. I would take my x, add 2, and it would become my y. This is known as a Venn diagram. We're going to be using Venn diagrams to decide whether something is a function or whether it's not. The goal of today is to be able to look at a relationship between inputs and outputs and deciding whether the relationship is a function or not. Now, we've been using the word function a lot. I suppose we should define what it is. Well, let's do that. Let me erase this. So, the definition. I'm gonna put some dots here. A function. A function is a relationship where every input, we're talking about x's, have exactly one output, namely y. Exactly one output. It means that whenever I put something into my machine, I put in a number and only one number comes out. When I take a input, any number I want, I put it in, and then I only get one number out. So using Venn diagrams to decide this, we're going to say this is a function. This is a function. And we're going to use a list of inputs and outputs to describe what a function is. So let's just say we have some numbers. We don't care what they are. We only care about whether it's a function or not based on the mapping. So let's just say I put in a 1, I put in a 3, I put in a 6, I put in a -5. And then numbers that came out were 2, 4, 16, and 1. When I put in a 1, a 4 came out. When I put in a 3, a 2 came out. When I put in a 6, 16 came out. When I put in -5, 1 came out. If you notice, some lines crossed here, some went straight across. That doesn't matter. The only thing that matters, every time I put in one number, meaning the number 1, the number 3, the number 6, the number -5, did it produce exactly one output? Meaning, did only one number come out when I put in the number 1? I can look at this mapping and decide, well, when I put in number 1, the number 4 came out. No other time did I put in a 1 and then something besides 4 came out. So when I put in a 1, 4 came out. When I put in 3, 2 came out. When I put in 6, 16 came out. When I put in -5, 1 came out. This is an example of a function. Every input, remember these are the inputs, produced exactly one output. Well, how would this look differently if this was not a function? Let's take the same numbers in the same Venn diagram. We had 1, 3, 6, -5, and then 2, 4, 16, and 1. And the mapping looks similar. For example, 1 went to 4, 3 went to 2, 6 went to 16. But then when I get to this -5, what happens if I put in -5 and it produces a 16 and a 1? What happens when I plug in -5 and out comes a 16 and a -1? I'm looking at this section right here. What this basically means is when I put in -5, out produced a 16 and a -1. When I put in one input, it produced 2 outputs. That does not fit my definition. I need every input to produce exactly 1. This mapping is not an example of a function because the number 5 produced 2 outputs. Now, it doesn't matter if I put in a 6 and 16 came out, and I put in -5 and 16 came out. That doesn't matter to me. Think of these like students, and think of these like classrooms. One student has one classroom. Is it possible for one student to have two separate math classrooms. I should have started over. These are math classrooms, right? You can have two separate classrooms, but one math. One student, one math classroom. One student, one math classroom. It's okay for a student to have separate math classrooms, but you can't have two at the same time. Okay, not my best analogy, but hopefully you get the point. If we understand what is a function and what not a function, we can take it a step further when we're talking about ordered pairs. When we're talking about ordered pairs and tables. So for example, let's take tables for example. We have an X and a Y. And then we have some values in our table. 1, 2, and 4. It means when I put in a 1, maybe a 5 came out. When I put in a 2, maybe a 6 came out. When I put in a 4, maybe a 10 came out. This is an example of a function. Because every input, meaning X, produced exactly one output, meaning Y. 1 produced 5, 2 produced 6, 4 produced 10. An example of not a function would be, say, X and Y. Let's just say I put in a 1, a 5 came out. I put in a 2, a 6 came out. But let's just say I put in a different 2, or I put in the number 2, and then a 7 came out. You'll notice that when I put in the number 2, a 6 came out, and I put in the number 2, and a 7 came out. This is the same thing as saying 2 produces 6, and it produces 7. That's not okay. This is not a function. If you're looking at a table, you're looking for duplicate inputs that produce separate outputs. You're looking to see, is there more than one 1, more than one 2, more than one 4, more than one 1, more than one 2, and to see if they produce different outputs. If the number 2 produces two separate outputs, you know it's not a function. What about ordered pairs? Ordered pairs. So for example, remember, we just have to keep in mind, before I get started on this, we have to remember that the first number is X, the second number is Y, right? These are like coordinates. So in ordered pairs, let's just say 1 and a 5. That means that 1 came in, 5 came out. 1 got put in, 5 came out. And then we have like a 2 and a 3 came out. And then a 3 and a 6 came out. This is considered a function because the number 1 came in, 5 came out. 2 went in, 3 came out. 3 went in, 6 came out. 1, 2, and 3 each produced only one output. This is considered a function. Whereas 1 came in, 1 went in, 5 came out. 1 went in, 3 came out. And then 3 went in, 6 came out. Remember, these are X's and Y's. The number 1 went in, 5 came out. The same number 1 went in, and 3 came out. This is the same thing as I put in a 1, out came a 5, and out came a 3. That is not okay. One input produced two outputs. That is not our definition. You need exactly one output. Therefore, this is not a function. The number one misconception about this lesson will be, do you have to understand what happens to the input to produce the output, like we did back when we were understanding those little machines back in like second grade, third grade? And the answer is no. The point of today's lesson is to be able to look at data, whether it's a table or an ordered pair, and be able to decide whether the relationship is a function or it is not. To do that, you merely have to look at the definition. A function is a relationship where every input, meaning every X, has exactly one output. If you can decide what inputs are on tables and what outputs are on tables, you're in great shape. If you can decide what inputs are on tables and what outputs are on ordered pairs, then you're in great shape. Or even in the Venn diagram, understand that we're just trying to know whether one input produces one output or if it produces more. If it produces one output, every input has one output, it's a function. If every input does not have exactly one output, it is not a function. I hope this video helps. Tomorrow, we'll be discussing what does it look like on a graph. That's all for today's video. Peace.